This is the flame test experiment. In this experiment, we will observe the color of light that is emitted as electrons fall from an excited state back to their ground state. Before we begin, let's review a few terms. On the board, you can see the colors of the rainbow from red to violet. The three variables that will be associated with this experiment are energy, frequency, and wavelength. As we go through the colors of the rainbow from red to violet, the energy will increase, meaning red has the lowest energy and violet has the highest. Since energy and frequency are directly related, red will have the lowest frequency and violet will have the highest. However, the wavelength has an indirect relationship with both energy and frequency, meaning that the red light that we may see during today's lab would actually have the longest wavelength, while violet would have the shortest. For this experiment, you will need your Bunsen burner, an empty beaker, a straker, and samples of the following atoms: barium, calcium, copper, iron, potassium, sodium, and strontium. As you can see, there are wooden splints in each of these samples that we will be using for testing purposes today. For the safety of this lab, please be sure to wear goggles at all times. Do not put your hand or any other object into the Bunsen burner flame, and tie your hair back if you have longer hair. To start the experiment, take the empty beaker and fill it with water. This will be the beaker in which you extinguish any flame that may arise on your wooden splint. It'll also help to be sure that the splints are cool before we dispose of them in the trash. Next, we are going to light the Bunsen burner by turning on the gas valve and using our straker. You should observe your two blue cones, the inner blue cone and the outer blue cone. We are now going to begin testing. Choose one of our samples to begin with. I'm going to go in the order of the data table. First, we're going to test barium. Taking our wooden splint, we're going to hold it in our flame and observe the color. The color may be hard to see on video, but in person, you would observe a predominantly green flame at first that turns over into a more orangish color as the stick itself begins to burn. For our data purposes, please record green as the color of this flame. Extinguish your still hot flame into your water beaker and continue on. Next is calcium. Again, we will insert into the flame. Hopefully the color on this one is a little bit easier for you to observe at home. The color appears to be a deep red. Please record deep red in your data table. Next is copper. I think it's pretty safe to say that the color of the copper flame is green. That orange that you're starting to see is the stick itself burning. Next is iron. The color of the iron is a little bit hard to observe, but if you look at the edge of the flame, you should see that there is an orange color coming off of our iron sample. There it is nicely. Again, we extinguish our flame that may have formed on our stick before continuing on to potassium. Did you see the color of the flame? If you did, you saw purple. For potassium then, in your data table, record purple. Extinguishing our flame and going on to sodium. This is a very bright orange color being emitted from our sodium sample. So I would record bright orange in my data table. Our final test is on strontium. The color of this flame, I would call this red. There it is nicely. Once you have tested all of your samples, turn the gas off to extinguish your Bunsen burner flame. For cleanup purposes, you can take all of these wooden splints and put them in the trash can, as they are now cooled from being in the water beaker. For the analysis and conclusion questions, be sure to read the questions carefully. For question 1, you are going to rank the atoms from the shortest wavelength to the longest wavelength based upon the color of light they emitted as their electrons fell from their excited to their ground state. For question 2, you will rank the atoms this time in order from the lowest frequency of light emitted to the highest frequency of light emitted. Question 3, you will rank your atoms from the lowest energy light emitted to the highest energy light emitted. For question 4, it asks you to identify the atom whose excited state was furthest from its ground state. Would this correspond to a high or a low energy? Once you know that, you'll be able to answer this question. For the final question, I want you to design a firework that changes from green to red as it bursts. Which atoms would you use and in which sequence? Refer back to your data table for help. This is the conclusion of the lab. At this point, students could return their goggles to their proper storage location, be sure their stations are cleaned up, and submit their work.